some math. Okay, we're solving quadratics, and we're also graphing them today. So what that means is, yeah, we're solving them like you did the day before, but we're also taking the information that we did long before Thanksgiving break, as far as getting the vertex goes from standard form, and we're going to just use the roots, aka zeros. We're going to use those and the vertex, and those will make 3 points that we'll use to graph our quadratic. So first off here, what we're going to do with each of these problems, we're going to find the vertex. Remember, using standard form, the vertex is the x value of the vertex is found by doing the negative b over 2a business. But that's only the x part of the vertex. To get the y value of your vertex, remember you have to plug the x back in to find y. So you do that, you find the x value by doing negative b over 2a, you plug that into the equation to find y, and bada bing bada boom, you've got your vertex. Now we still need a couple other points to be able to draw the quadratic, and technically you need a minimum of 3 points. That's where the roots come in. So we're going to factor the quadratic equation, and we're going to find the zeros by solving it, and then those zeros are where it touches the x-axis. Now we have 3 points, and we can make a happy little sketch. So first example, I've got y equals x squared minus 2x minus 3. So I figure out what is negative b over 2a. Well, let's see here. Negative b, which is negative 2, over 2a, a is 1. Okay, so then I simplify this down. I've got a double negative, which is just positive 2, over 2 times 1 is also positive 2. That divides to just be 1. That's the x value of my vertex. Okay, now I need to figure out the y value of my vertex. I'm just going to plug this back in right up here. So that's 1 squared minus 2 times 1 minus 3. Well, let's see here. Simplify that. That's 1 minus 2 minus 3. 1 minus 2 is negative 1. Negative 1 minus 3 is negative 4. So then my vertex is 1, negative 4. That's my vertex. Now I need to go back here. I need to factor this equation and solve it in order to tell what the zeros are. So factoring, let's see what multiplies to negative 3 and adds to negative 2. That's going to be negative 3 and positive 1. So I write that x minus 3 and x plus 1. Then using that, I can tell that the zeros have to be just the opposite signs. So x equals 3 and x equals negative 1. I now have 3 ordered pairs, three points to plot here. I've got the vertex, which we just said was 1, negative 4. I've got the 2 zeros, the x-intercepts, which are 3 and negative 1. So then using that information, I have everything I need to make this graph. In fact, I actually have one extra piece of information. Remember that the c value is always the y-intercept here, so in standard form. So I can, if I want to, I can come over here to negative 3, and I can put that point as well, which means that I have a mirror image point, a symmetrical point right here as well. But, you know, sometimes it's helpful, sometimes it's not. So I can make my sketch. Voila. Not a pretty one, but it's good enough. And we see the next example here. Oops. Okay. So this time a little bit different because we've got an a value that's not 1. So I got to multiply 4 times negative 5. Wait, hold on, I'm getting ahead of myself for factoring. Let's find the vertex first. So negative b, which is negative 8, over 2 times a. That Double negative ends up being positive 8 over positive 8, which again is 1. If I plug 1 back in, I get 4 times 1 squared minus 8 times 1 minus 5. Okay, so simplify that. That's 4 minus 8 minus 5. 4 minus 8 is negative 4, and minus that other 5 makes negative 9. So then my ordered pair for this is 1, negative 9. And I can even graph that over here. 1, negative 9. And for those of you keeping track, once again, I can go on ahead and I can graph that y-intercept, which is negative 5. 1, 2, 3, 4, 5. But that's not the goal here. The goal is I want to get the zeros, the x-intercepts, the roots. So here's where I have to find the multiply number. The multiply number is negative 20. The add number is negative 8. Well, what multiplies to negative 20 and adds negative 8? That would be negative 10 and positive 2. Okay? So again, those are my numbers that multiply and add here. So I'm going to write that out. I've got y equals x minus 10 and x plus 2. But I have to do bottoms up. I have to divide by this 4. So divide by 4, divide by 4, and both of these simplify. It doesn't divide perfectly, but they both simplify. 10 over 4 can be simplified down to 5 over 2. So if it's 5 over 2, okay, like that, and this simplifies to 1/2. Now I can, oh whoops, write that as 1/2. Now, of course, bottoms up has me pull the both of those 2's up in front of the x's, but remember, we're looking for the solutions. The solution is just going to be the opposite sign to both of these. So since really that's what I'm interested in, I need to know that the answers are 5/2, positive 5/2, and negative 1/2. Okay, but yeah, the factored form would be 2x minus 5 and 2x plus 1, but we're not looking for that quite so much here. So now I've got 5/2 and negative 1/2. Well, as a decimal, 5/2 is 2.5. 2.5 is right here. Okay, and then negative 1/2 is just right here. So now I've got my zeros, I've got all the points that I need. I'm going to sketch this very poorly, I might add. Whoa, way off, but okay. That's what you do. Again, bottom line here is negative b over 2a. To find the x value of your vertex, plug that back in, find your y value. Then factor it using any method that you need to. And from when it factored form, change those signs to get the solutions. Once you have the solutions, you've got your x-intercepts to graph, you've got your vertex to graph, you have everything you need to graph a quadratic equation using the factoring technique. Alright, go back and watch anything else that you need to, and write a good summary here.